Oh, hello everyone. This is me, Kalam Hussain here, and I'm going to present my 13th practicum of Max second semester. And I'm going to present the questions and the code, and after that, the output of the questions. So let us dive into the first question. First question, which is website traffic prediction. A web analytics system records the relationship between the number of daily visitors and page requests in thousands. Here's the visitors which are given as 1,000, 2,000, 3,000, 4,000, 5,000. And page request is as follows: 20, 15, 28, 40, 55, 68. And we have to predict the page request when visitors reach 6,000 using the least square straight line fit. And onto the code, which is we are you importing import numpy by as the np, and after that we are importing matplotlib dot py plot as plt, and after that we are implying the x values. X is equal to np dot array 1,000, 2,000, 2,000, 3,000, 4,000, and then 5,000. And after that we are applying value y values, which is np dot array is equal to 15, 28, 40, 55, 68. And after that we are using as n is equal to length of x, and after that sum x is equal to np sum x, sum y is equal to np dot sum y, sum xy is equal to np dot sum xy. After that we are using x square, np dot sum x square. After that we are using the least square coefficients. M is equal to n times sum xy minus sum x times sum y divided by n sum of x square. Sorry, it's not x square, it's x2, and minus x square, sum of x square. Okay. And after that, we are using b as sum y minus m sum x divided by n. After that, we are printing out the slope m. And after that, printing the intercept h, b. And after that, we are printing the straight line equation. After that, we are printing out y is equal to round bracket m comma 4 m comma 4 bracket x, not bracket ending, comma x plus round b comma 4. And after that we are predicting the x values as 6,000 and y is equal to mx prediction plus b. And after that we are predicting the page requests, and after that we are plotting um, the graph. Plot a scatter xy, plot a plt plot x mx plus b. And after that we are labeling visitors in x-axis as visitors, y-axis as a page request. And after that we are giving the title least square straight line fit. And after that we are showing onto the output, which is the slope is 0.0133. And after that we are the intercept b is 1.3. And after that the straight line equation is y is equal to 0.0133x plus 1.3. After that, the predicted page requests is 81.1. And onto the graph, which is as me shown here, it's the for 5,000, it's reaching around like 60 to 70 here. And so this is the first one's output and a diagram for the slope. And on to the second question, which is a database query response time prediction. Database administrator measures the relationship between number of executed queries and average response time. The queries are represented as in X, and response time is represented in Y. And after that, we are going below. The queries are arranged like 50, 100, 150, 200, and 250. And the response time are arranged in such a way like 20, 35, 48, 60, and 75. And after that, we got to predict the response time, and the 300 queries are executed. Onto the code, which is uh, kind of similar. We are importing numpy by as a np, x is equal to np array 50, 100, 150, 200, and 250. And after that y is equal to so and so the given value which has been given in the question. And after that we are importing n is equal to length of x, sum of x is equal to np dot sum x, sum y is equal to np dot sum y, sum xy is equal to np dot sum xy. After that sum x square is equal to np dot sum x square, m is equal to n times x sum xy minus sum x sum y divided by n times sum x2 minus sum x square. And after that, we are printing out b is equal to sum y minus sum y minus m sum x divided by n. And after that, we are printing the slope and intercept and straight line equation. And after that, we are printing the response time as given here. The response time y is equal to around m4x round B4. And after that, the x spread is 300, y spread is equal to mx spread is B. And after that, we are printing out the predicted response time. And after that, we dive into the output, which is the slope is 0.27, the intercept is 7.1, the straight line equation is response time y is equal to 0.27x plus 7.1. And after that, the predicted response time is 88.1. And on to the third question, which is the machine learning training time estimation. A data scientist records the relationship between the data set size gigabytes GB and a training time in minutes, and the data set size is given in the such a way which is 2, 4, 6, 8, and 10. And training time is 10, 18, 28, 35, and 45. We got to predict the training time for 12 GB data set. So we got to predict the training time here. And on to the output code. First step is to import numpy by snp, and we are uploading the values x and y into the mp.array, which is 2, 4, 6, 8, 10. And for y is 10, 18, 28, 35, 45. And after the n length x is equal to sum x is equal to so on np dot sum y is equal to np dot sum y. Sum xy is equal to num xy, sum x square is equal to np dot sum x square. And the formula is given as n sum xy minus sum x sum y divided by n by sum x square minus sum x square. And after that, we are printing out b is equal to sum y minus m sum x divided by n. And after that, we are printing out the slope, intercept, and straight line equation. After that, we are printing out the training time. Y is equal to round m4x plus round b4. X predict is 12, y predict is equal to mx predicted plus b. And after that, we are printing out the estimated training time, which is y predict. And after that, we are printing out and the output which has been occurred here is the slope is equal to 4.35 and the intercept is 1.1. And the straight line equation training time y is equal to 4.35x plus 1.1, and the estimated training time is 53.3. So there you go. These are the three codes which I have determined, and these are the output which I occurred with it. Let us scroll up and let's go into a glance. Once again, for the first one, here's the output which of the code which I occurred, and the graph which has been occurred. And onto the second one, here's the output here, and to the third one, which is this, and this is the output. So there you go. This is the overall codes for the Practicum 13, and that's it. Thank you.